Okay, so we're going to talk about permutations and combinations today. So have you guys seen this symbol for factorial? Like, no. Right? Have you seen this symbol for factorial? That's like an exclamation point, right? So what that means, right? So if I have, for example, 8 factorial, it's not like, oh, 8, right? Like I'm not excited about the 8, but it's basically like that number. So it's the product of all the integers starting with that number and going down to 1, right? So 8 times 7 times 6 until 1. So that's what a factorial is. What you absolutely need to remember, and we'll talk about this later, is 0 factorial is 1. Okay, 0 factorial is 1. Okay, now let's talk about permutations. Permutations are when you have objects that are arranged so that their order is important, right? Each possible is a permutation, okay? So for example, if I have, like the 3 of you, right, sitting like this is one permutation, right? But if you guys were now switched, right, that would be a different permutation, right? So the way you're sitting is a permutation. It's how many different ways there are to arrange you. So this is one way to arrange you, right? And then if I had, for example, Jacob, Liam, and Akiva, that would be another one, and so on. Okay, so each of those is a permutation. And factorials are what is used to find a permutation. Okay, so look at this one. Erica, Jasmine, Tara, and Becky are on a softball team, and the coach wants to consider all the possible ways the 4 players could bat first, second, third, and fourth. Okay. Okay. So first, second, third, or fourth, right? So one possibility is if it's Erica, Jasmine, Tara, Becky. Another possibility is if it's Tara, Erica, Becky, Jasmine, right? So we want to know what are the different ways. So there are 4 people batting, right? For the first person to bat, we have 4 options to choose from. For the second person to bat, you have 3 options to choose from, then 2, then 1, right? And from yesterday, right, the total number of ways is 4 times 3 times 2 times 1, which is 4 factorial, okay? And that's 24, okay? So this is how factorials are used to determine permutations, okay? Now, Ray and 5 of his friends want to go see a movie. In how many different ways can they sit together in a row of 6 empty seats? Well, again, this is going to be 6 factorial, which is 720. Now look, okay. Oh my God, listen. Okay, so one way we use factorials to our advantage is, so if I have 6 factorial, this is 6 times 5 times 4 times 3 times 2 times 1. But that is 4 factorial, right? So I know that this is 30 times 24, okay? So we can use factorials to our advantage that way. Okay, so take a look at this next one. A teacher has 30 students in a class and wants to select 3 students to go up to the board one at a time. How many different ways could this occur? So we're going to select one student, then another, then another. The first time she's selecting a student, there are 30 possibilities. The second time there are 29. Then there are 28 possibilities. So there are 24,360 possibilities. But now, listen, we can't keep writing out numbers like this, because what if you have like a larger order of numbers? There has to be a more efficient system to do this. So let's figure this out. If I had done, because I have 30 students, right? If I had done 30 factorial, okay, that would have been 30 times 29 times 28 times 27, blah, blah, blah. Okay? But, okay, listen. That would have been, if I were selecting 30 of the students, all 30 of them, how many different ways there are. But now I'm only selecting 3. Now, I already know that this is my answer. So basically, anything else that comes out of that, I'm not going to need it anymore. What does come after this? It's 27 factorial. So if I were to divide this by 27 factorial, that would cancel and I would get what I want, right? So then my formula sort of becomes 30 factorial over 27 factorial. What is that? 30 factorial is how many students I have. Out of those 30, I'm selecting 3. 27 are not being chosen. So I divide out the 27 factorial that are not being chosen. And this brings us to the permutation formula. So if you have a number of permutation of n objects, this is the total of objects, 30 students, you're taking r at a time, 3 at a time. The formula is this. It's a permutation of n taken r at a time. It's n factorial, n minus r factorial. So for instance, if you had a permutation, you have 50 objects and you want to choose 6 of them. It's the first number factorial. Then subtract 50 and 6, 44 factorial. That's how we do it. Okay? So let's do some practice with these numbers. Okay, so take a look at this. For some of them, we'll have calculators and for some not. So let's try to do both versions, okay? So here, 10 factorial is 10, 9, and then 8 factorial, right? Divided by 8 factorial. So look, I stopped where the denominator was. These cancel, and so now this is just 90. You see how efficient that is? So in this case, look, I have 16 factorial over 12 and 6 factorial. So I'm going to use that to my advantage. 16, 15, 14, 13, 12 factorial over 12 factorial. Right now, these are going to cancel. But the 6 factorial, let me write it out. So look, the 12 factorials cancel. Now look at what I have. I have a 15. That cancels with the 5 and the 3. Right? Because I can do that. And then I have a 2. I can reduce that with the 14 and get a 7. I mean, really, there are so many other possibilities, right? Let me just write down what I have so far. You can do so many things, okay? 6 times 4. And now look, the 6 and the 16, I get a 3 and a what? 8, right? I can do more. Oh, the 4. 1, 2. So what do I have? 14 times 13, that's 182 over 3. Okay? So what was seemingly very complicated, I was able to just reduce. Okay, this one. You need to remember the formula. So it's 7 factorial, the first number factorial. Then you subtract 5 factorial. So this is 7 times 6 times 5 factorial over 5 factorial, 42. 6 factorial over how many? 2 factorial. So this is 6 times 5 times 4 times 3 times 2 factorial. 12 times 30, 360. Okay? Yeah. So the librarian is placing 6 out of 10 magazines in a school showcase. How many ways can she arrange the magazines in the case, right? So again, like it makes a difference if you have like, I don't know, Car and Driver, then National Geographic, then Time magazine versus in a different order. So that's why this is a permutation, okay? Permutation of choosing 10 out of 10, 6 objects. This is 10 factorial over 4 factorial. what did I do? 10 times 9, 8, 7, 6. Okay, so this one, obviously, calculator, 151,200. That's how many different ways. Isn't that crazy? That's how many different ways there are to arrange 6 of the 10 magazines. Because you're not just arranging 6 magazines. You're not just arranging 6 magazines. It's which 6 of the 10 are you choosing? And then how are you arranging them? Right? Yeah. Okay. Now, what if there are permutations? What if there are permutations with repetition? So what if you have 2 identical copies of the National Geographic, right? And so it doesn't matter if you put them like this or if you put them in the reverse order. It doesn't matter because it looks the same, right? So in the permutation, we have to have a way to remove those, to extract those, right? And so the way that works is if you have a permutation, okay, so if you have a permutation and some things are being repeated, if something is repeated R1 times and R2 times, you have to divide it out. Okay? So take a look at this one. You're given these letters and you want to unscramble them to name a US river. If you selected, okay, so here's the question. We all know it spells what? Okay, so now, okay, so here's the situation. If you just threw these up in the air and they just landed, what is the probability that they would spell Mississippi? Now, the situation though is the following. If these tiles just landed on the floor, right? If you have this I and this I switched, you wouldn't know it, right? You wouldn't know it. And so we have to take those out. Another thing that is important about this question is we're not being asked the total number of permutations or how many different ways there are to arrange them. We're asked for the probability that we get Mississippi, okay? So it has to be the favorable outcomes over the sample space. So for the sample space, first we need to figure out how many permutations there are. So I have 11 letters total. So the number of permutations is 11 factorial over. Now, how many times do the I's repeat? So 4 factorial. How many times do the P's repeat? 2. How many times do the S's repeat? So over 4 factorial, right? So that is 34,650. This is how many different ways the letters can be arranged, and you've taken out the repeats, right? But how many of those arrangements is what we want? Just one, just the Mississippi. So the probability is 1 out of this. Yes. No. It'll be 4 times 2 times 3 times 1 times 8 times 6 times, yeah. It repeats, yeah. Okay? Okay. This was a permutation, right? Now, a combination is different. A combination is the following. Suppose I have 3 board markers, 2 of them are black. How many different ways I can arrange them, right? So look, I can have black, blue, black, or I can have black, black, blue, or I can have like blue, right? But does it matter if I have blue, black, black, but the 2 blacks are switched? That's a combination, okay? So a combination is where order is not important. Or another way, yes and no. Let's take a look at this for a minute. Look at this one. Choose three different pizza toppings from a list of 12. So from a list of 12, you chose 3. Suppose you chose onions, olives, and mushrooms. Okay, onions, olives, and mushrooms. Does it matter if you said mushrooms, olives, and onions? No, the pizza is going to look the same, right? So that's a combination. Okay? Correct. There is no order. Choosing team captains for a football team. So if I just wanted to choose 2 team captains, combination, because does it matter if I say it's Liam and Akiva or Akiva and Liam? You see what I mean? So, okay, listen, I will specify right now. Yes. Choosing first, second, third place winner of an art competition, that's a permutation, because I can't just say, okay, you 3 are the winners. No, it matters who's first, who's second, who's third. So let me tell you another example. Suppose I said, that is not permutation. I don't know what that is, but okay. So suppose I said, give me your 3 favorite movies of all time versus can you rank your 3 favorite movies of all time? Those are different things. One is a combination, one is a permutation. Okay? Okay. Now, the combination formula has to take out the repetitions, right? So it's the permutation, but I also have to divide by, like if I said Akiva and Liam and Akiva, I have to count those 2 as 1. You see that? Okay, so for example, if I were to choose 2 out of your 3, right? I wouldn't say, okay, one option is Jacob and Liam, another option is Liam and Jacob. I wouldn't say that, okay? So the formula is now this. Now it's a combination, n factorial over n minus r factorial. You have to memorize this formula, but it's so easy to do because look. Yeah, exactly. So look at this one. So what we were doing before is 8 factorial over 6 factorial, right? Now just add the other 2 factorial. That's all. It's the same as before, you just divide by the 2 factorial. Because you take out, you know, like the Akiva and the Jacob and the Jacob and the Akiva, right? Correct, no. But let's do this on the calculator. Go ahead and take out your calculators. Okay, so it's either, okay, so listen, it's either, so let me do this. It's either in there, in this button, oh. So it's either in that button, or you can do, what was the first one? 8. You can do control and the book. It's there as well. And if you use it one time, it's there. 8 factorial over 6 factorial. Oh, shoot. I mean, how often are you using the factorial anyway? So you guys can, you'll live. Don't worry about it. Yeah, it does. So you don't have to like get there every time. Okay? 28. Now, if I tell you to write it out and show your work, you have to write it out and show your work. Like here. 10 factorial over 5 factorial, 5 factorial. So this is, okay, that was too big. 10, 9, 8, 7, 6, 5 factorial. 5 factorial cancels. Then I have 5, 4, 3, 2, 1. Right? Okay, so these go away. And then what do we have? We have, look, 5 and 2 cancels with the 10. Right? 4 and the 8 will cancel. Let me do that in the red. So, yeah, let's do 3 and 9. What do you think? So what do we have? We have 3 times 2 times 7 times 6 over 1. Is that 252? All right. Okay, so the department store manager wants to create 3 display for 3 mannequins, right? A display for 3 mannequins. How many ways can she choose from 20 different shirts? So here, this is a combination because it really doesn't matter the order in which she chooses them. She just chooses 3 of them, right? So this is a combination, 20 with 3. Now, this is going to be 20 factorial over what? Okay, now look, go back to your calculator. Let me show you this. You're going to love this. You ready? Press menu. Press probability. Combinations. Baruch Hashem. So 20, comma, 3. The syntax is N, comma, R. Press enter. Whoa!
Hold your horses. Where's comma?
Comma is to the very left of the O, under the pi. Yeah. The syntax is N, comma, R.
That's great.
Now you know what you paid $140 for.
Yeah. $140 to quickly solve something.
Okay. Wait till you get to some of the other stuff. Yeah. Okay. Take a look at this straight out of geometry. Okay. If 3 points are randomly chosen from those named on the rectangles shown, so A through H, what is the probability that they lie on the same line segment? So 2 things are happening here. Hang on. First is we're picking 3 points. Now, is this a permutation or a combination? It's a combination because it doesn't matter if I pick, BCD or CBD, right? It doesn't matter. So it's a combination. So first I'm going to do the sample space.
CBD aren't hard?
It doesn't matter. It doesn't matter because the first line of attack is 3 out of the 8. Okay, first we're going to choose 3 out of the 8. So how many different ways are there of choosing 3 out of the 8? So for example, I can pick GHA, I can pick FDB, I can pick HDE, right? 3 out of the 8. So this is going to be a combination from 8. We're choosing 3. Use your calculator. Tell me what you get. 3. Okay. Now look. Look at the 3 I chose here. Which one of these will work? Is GHA a favorable outcome?
Yeah.
Yes. Is FDB? Is ADE? No. So these are the ones I want. Okay? Now, how many of those are there? This is one, this is one, this is one, this is one. I have 4 possibilities. So the probability is 4 favorable outcomes out of 56, 1 over 14. Okay. A teacher wants to form a committee of 5 students from his 32-student class. How many ways can he choose the committee? Is this a combination or a permutation? Combination. Okay, so do it. Correct. Okay. Okay. A password is formed by 4 different letters from the alphabet. What is the probability that someone guesses the password on the first try? Is this a permutation? Permutation, right? Because it matters if you have, okay. So, it's a permutation. Okay. Okay. It's a permutation. From the 26, we're going to choose 4. So this is the sample space. Right? But this time, when I do menu probability, this time I want to choose number 2 for permutation. Okay? And then the syntax is the same, 26, 4. Right. It's 358,000. 800. Now, how many favorable outcomes are there? One. There's one password. So the probability is 1 out of all this. To get it on the first try, correct. Okay? All right. So that's it. And then the homework for this is a worksheet.